Today we have linear approximations. So we are going to use linear approximations to basically approximate the function at x, which will be listed here. So let's go ahead and do that. So we're just going to use an approximation to find an approximation for the function. And then let's go ahead and use the calculator to compare our approximations with the approximation of the calculator. So let's go ahead and start with number one. We have a cosine of 47 degrees, right? Cosine of 47 degrees. So in order to calculate, well, approximate this, we're going to have to know basically a value that we can already calculate with, without a calculator, a value that we already know of cosine that's close to cosine of 47 degrees, right? So what value can we calculate that we already know? That will be cosine of 45 degrees, right? And what does cosine of 45 degrees equal to? The square root of 2 over 2. So we already know that, right? And the square root of 2 over 2 is roughly going to be equal to, I don't know, like 0.7 something. That doesn't matter right now. 0.7, I don't know. Yeah, that doesn't really matter right now. So 0.707 something, whatever, like that. Okay, so cosine of 47 degrees. We already have cosine of 45 degrees, which is going to equal to the square root of pi, the square root of pi, the square root of 2 over 2. And now we are going to choose this as our a value, okay? So let's choose 45 degrees as your a value. Good. So 45 degrees will be your a value. Okay, so basically you'll see why we're going to choose 45 degrees as our a value. So let's go ahead and I'll show you the equation, the formula we're going to use. We have L of x is equal to f of a plus f prime of a, which will be the derivative, times x minus a, or the change in a, whichever you prefer. So that will be basically the linear approximation that we are going to use. So let us do this. F of a, it's already asking for f of a. So what did we choose our a to be? We chose 45 degrees to be our a, right? And when we plug in 45 degrees into our function, let's define our function. So our function f of x is going to be cosine of x, right? So that's our function. That is our function right now. So we already defined our function. That's our function, and it's asking us to plug in a. So 45 degrees is a, and when we plug in 45 degrees into cosine of x, what are we going to get? We're going to get the square root of 2 over 2, right? So this will be the square root of 2 over 2 plus f prime of a. And that prime means that we need to find its derivative. So we need to find the derivative of our function, which is cosine of x. So let's go ahead and differentiate this cosine of x, right? So we have d of x of cosine of x, cosine x. And as we all know, the derivative of cosine of x is negative sine of x, right? Negative sine x. That's going to be our derivative for cosine of x when you derive this. So now we can go ahead and plug in f of a into our negative sine of x. So negative sine of 45 degrees, what is that? That is going to be negative, oops, I put a plus sign, but whatever. Negative square root of 2 over 2, rad 2 over 2, right? So now x minus a, we need to subtract our x minus our a. So our a, 45 degrees, and our x, what is our x? 47 degrees. But we cannot use degrees here. We're gonna have to convert the 47 degrees and the 45 degrees to radians. So let's go ahead and convert that now to radians before we plug it into this part of our linearization. So 45 degrees, actually let's convert 47 degrees into radians first. So we have 47 degrees and we want to convert that into radians. How do you do that? That is easy, just multiply by pi over 180. 47 multiplied by pi over 180 is going to give you to 47 pi over 180 radians. So that is how you calculate it to radians. And we know 45 degrees is equal to pi over 4, right, in radians. So we don't have to calculate that. So 45 degrees is pi over 4. So 45 degrees is pi over 4. So 45 degrees equals to pi over 4, right? Pi over 4, right? All right, now let's go ahead and plug in our change in x, change in x. So our x was the 47 degrees, right? That's our x, and our x right here converted to radians is 47 pi over 180. Let's go ahead and put it here. 47 pi, 47 pi over 180 minus our a, 45 degrees, pi over 4, minus pi over 4. So let's go ahead and put that into the calculator. So first let me find out what 47 let me just go ahead and input this into the calculator. So we have let's see if this works. I haven't done this. Rad 2 divided by 2 minus the square root of rad 2 divided by 2 multiplied by, let's see if I can do this. I haven't done this before, so let's see. 47 pi divided by 180, right? Minus pi over 4. Shift pi divided by 4. Now let's see if this works. This will give us, oops, I don't think you were able to see that. Sorry about that. But this will give us roughly 0.6. Let's write it down. So our approximation, if you couldn't see, all I did was just plug this into the calculator. That's literally it. You can do the same. Our approximation, this will be our approximation. So our approximation. Our approximation, that's what we calculate, right? So according to the calculator, we got, let's write it down, 0.682424098. And we don't really need that many values, but whatever. 0.682424098. All right, good. Now let's go ahead and use a calculator's approximation. Calculator. Let's see what our I probably misspelled that. Calculator. Yeah, I probably misspelled that, but let's see what our calculator tells us what the sine of 47 degrees is. So let's go ahead and make sure our calculator's in degree mode. So degree mode, cosine of 47 degrees, right? Our calculator tells us that it's 0.681993. Yeah, we're just gonna leave it at that. So 0.681993. You can see how we're pretty much close. Our approximation and our calculator's approximation were pretty much close to each other. So that is how you do number 1 to approximate this using our linear approximation. Let's go ahead and go on with number 2. Number 2 is also extremely similar to number 1, so let's go ahead and approximate that one. So sine of 62.3 degrees, it's in degrees, and remember we want radians. So, but let's just go ahead and do this right now. So what sine, pretty much what value of sine or whatever, what if we input a radian or a degree into sine, what do we already know? Sine of what? Sine of 60 degrees, right? And that is going to give you, what will that give you? Sine of 60 degrees, that's going to give us rad 3 over 2. So we already know that This we already know, so we're going to use that to evaluate this. So let's go ahead and again start with our L of x formula. L of x is equal to f of a plus f prime of a times x minus a, or the change in a. Good. So we have that. Again, sine of 60. The 60 degrees is going to be our a value, right? So 60 degrees, which we will turn in radians later, is equal to a. If you want, you can turn this into radians right now, but I'm just going to leave it like that. So 60 degrees is equal to a. So let's go ahead and basically take the derivative of our sine of x. Oh, let's define our function. F of x is equal to sine of x. Right? So that's our function. Now we can go ahead and take the derivative of our function and continue with our approximation. So d of x of sine of x is equal to what? The derivative of sine of x, as we all know, is equal to cosine of x. Right? Cosine of x. So now we can go ahead and basically do this. So that's our derivative, by the way. Let's go ahead and I didn't do this in the last problem, but let's just go ahead and label this as our derivative. F of x, f prime of x is equal to cosine of x. Sorry that I forgot this step, but you guys get it right here, so yeah. So f prime of x is equal to cosine of x, right? So now, well, this is just labeling. It's not that important, but this is just labeling. Okay, so we have f prime of x equal to cosine of x. We have, okay, f of a. What did we choose our a to be? We chose our a to be 60 degrees, right? And the cosine, f of a, which is basically our function. So our function is sine of x. The sine of 60 degrees is, as we already established, is rad 3 over 2, right? Rad 3 over 2 plus the derivative of f of a. So now what we have to do is take our f of a, which is 60 degrees, and plug it into our derivative. So the cosine of 60 degrees, what is that going to be? The cosine of 60 degrees is 1/2. Right? From the unit circle, we know all that stuff. 1/2. So that we will get 1/2 when we plug in 60 degrees into our derivative function, or derived function. So now let's go ahead and subtract x minus a, which is a change in a. X, what is our x? Our x is 62.3 degrees. Now we have to turn this, our x, into radians. Again, just do what I did here. Multiply by rad by pi divided by 180. And so we can turn it into radians. So knowing already the process of turning it into radians, that's going to equal to 62.3 pi over 180, right? That's how you turn 62.3 degrees into radians, because our x is 62.3 degrees. Therefore, that's why our this is there. So minus a. What is our a? Our a is 60 degrees, right? 60 degrees. What is 60 degrees in what do you call it? Radians in yeah, radians. 60 degrees in radians is pi over 3, right? 60 degrees is pi over 3. Again, you do this, 60 pi divided by 180, you just multiply that. That's going to give you pi over 3, right? So that, just a reminder on how to like convert to what do you call it? Radians. So let's go ahead and basically just use our calculator to approximate our approximation from our linearization. Whatever, doesn't matter. I don't know how to spell. That's okay. Let's see. Rad. This time I am gonna try and show you. Rad 3 divided by 2 plus 1/2 multiplied by the 62.3 pi over 180. That's 180, right? Yeah. Minus shift pi divided by 3, right? Close parentheses. 0.886096. Yeah, whatever. Let's go ahead and write it down. So that'll be 0.8860966902. Doesn't matter. That'll be our approximation. Let's go ahead and use our calculator. So let's see, what does our calculator tell us. So the sine, make sure it's in degree mode, your calculator. Sine of 62.3 degrees, right? Now our calculator tells us 0.88533936, blah, blah, blah. As you can see, we are also pretty close to the calculator's approximation. So that is how we approximate number 2. Let's move on to the last one. The cube root of 1333.45. Let's go ahead and do that. Again, our linear approximation, L of x, is equal to f of a plus f prime of a times a change in x, aka x minus a. So let's go ahead and first of all establish our function. So what is our f of x? What function do we see here? We see the cube root of x. And that's the function we see here. That's our function. So let's choose an a value. So let's choose a. What can our a be? What do we already know that it's multiplied by itself is going to give us a value very close to this value right here, our x. That will be 11, right? Because 11 times 11 times 11 is 1331. So choose a. Our a is going to be 11. Our a is going to be 11. Our a is going to be basically 11 times 11 times 11. 11 raised to that power. 1331. That's going to be our a, because the cube root of a, the cube root of a of 1331 is equal to 11, right? Because 11 multiplied by itself 3 times is going to give us this number. 11 by itself multiplied 3 times is going to give us that number. So that's why we chose our a to be 1331, because that's close to this value. Okay, so now that we chose our a to be 1331, and we already defined our f of x. By the way, we can rewrite our f of x as f of x is equal to x to the 1/3 power. Okay, so now let's go ahead and derive our f of x. The derivative of f of x, which is let's see, of x to the 1/3 power, is equal to 1 over 3 x, using the power rule. 1 over 3, let's see, minus 1 over 3 minus 1, that is negative 2/3. Negative 2. If you don't know the power rule, you just move this to the front, then subtract this by 1. You get 1/3 x negative 2 over 3. So that's going to be f prime of x. That's your derivative. That is your derivative. So let us go ahead and evaluate right here. So f of a. What is f of a? F of a is, remember, this is our function. Our a is 1331. If we move our a into our function of the cube root of x, the cube root of 1331 is, as we established, it's 11. So that is 11. Plus f prime of a. We put our a into our derivative. So f prime of a is going to be equal to, just plug this into your calculator, but f prime of a is going to be equal to, let's see, 1 over 3, 6, 3. That's going to be your f prime of a if you plug this into the calculator. If you put a in where x is, well, this could be put into an a, this can be like changed into an a. I kind of forgot to like change these into an a, but it doesn't matter, just as long as you get the idea, as long as you know where I'm getting these values from and what I'm doing. So yeah, so let's go ahead and get the change in a, which will be our x is this one, 1333.45 minus our a, which is 1331. I really should have labeled this as cosine of a instead of x, but I hope it doesn't cause too much confusion. I hope you guys know where I'm getting these numbers from and stuff. So, and this x does not usually correspond to this x, but it corresponds to our a. But you guys get the idea. Just change this to an a if you want. Just change this to an a if you want the derivative. Just change that to an a if you guys want. Anyway, let's go ahead and if you guys like have any confusion or something, just tell me and I'll fix it. But I'm gonna guess you guys know what I'm doing here. Anyways, so I went off on a tangent. Whatever, on a tangent. Anyways, 11 plus that stuff. Let's go ahead and plug this into our calculator. 11 plus 1 divided by what is that, 363, right, multiplied by 1333.45, right, 1333 minus 1331, 11 point, let's go ahead and write it down. Our approximation is roughly equal to, yeah, these little squiggly lines mean roughly equal to. I forgot if I said it equal to, but it's roughly equal to. This is just an approximation. It's not an exact value. 11.006749, and we're probably just gonna stop there. Now let's do our calculator. Calculator. Let's see what our calculator tells us. So the cube root, wrong one. The cube, let's see, the cube root, oh, hold on a second, sorry about that. The cube root of, what is it, 1333.45. 1333.45. What would the calculator give us? That will give us 11.006745, and you see that we're pretty much very close. We are very close compared to what the calculator gave us. So that is basically how you do this stuff, this linear approximation. Very good stuff in case you don't have a sine function or cosine function in your calculator. But whatever, it's a good approximation, good for approximating. So yeah, that's basically it. If like I said, I should have changed this x to an a rather than leave it as an x, because I don't want you guys to get confused with this x and this a. But I'm pretty sure you guys know what I meant as I was going through this. So if you guys are confused in any way, just let me know. Hopefully it's not confusing, and yeah, that's it. Good luck.